again, it's Mr. P, and we're going to look at some more problems that involve solving equations that contain square roots, and this would refer to section 10.4, part 2. Remember, in part 1, we solved equations that had square roots in them, and I said we would, in section 2, we would solve equations with square roots, but ones that were a little more involved that required factoring. Okay, so we'll bring back in some of our factoring skills when we solve today. So remember, in a square root equation, okay, we practiced this in the first part, we need to check our answers. We need to plug them into the original equation. Okay, so we may get two answers, but we need to plug them into the original equation because it's not necessarily both will work. Okay, one answer might work, both answers might work, no answers might work, in which case we would have no solution. But again, I put a reminder here, so remember to check your answers. Answers that don't work in the original equation when we plug them in, remember those are called extraneous solutions, and these are not included as part of your final answer. So when you enter your final answer, okay, you do not include these extraneous solutions. So let's go ahead and let's just start with an example here. So this is going to be the square root of 72 minus r, that's in the square root, equals r. So I want to solve that equation. Remember, to get rid of a square root, recall from part 1, we have to do what to both sides of the equation? Remember, we have to square both sides, and that gets rid of the square root. So I'm going to go ahead and square both sides. So I have r squared on this side. Remember, square root goes away on the left. I have 72 minus r. Okay, so remember, okay, we have an r squared here, so we're looking at a quadratic equation. Remember, in order to solve a quadratic equation, whether we factor, which we're going to do, or whether we do quadratic formula, one side always has to be equal to 0. So I'm going to go ahead and subtract 72 and add r to both sides. So I have 0 equals r squared. Remember, we put the r term next, so this would actually be plus 1r minus 72. Okay, so once it's equal to 0, we're ready to go ahead and solve. If we can factor, we want to factor. And so remember, when we factor something like this, where there's no number in front, we look for factors of negative 72 that add up to positive 1. Okay, so we're looking at some combination of 9 and 8. So we know that 9 and negative 8 add up to positive 1. So we factor. So r plus 9, r minus 8. Remember, we set each factor equal to 0. So r plus 9 equals 0. R minus 8 equals 0. And subtracting 9 over here, I get r is possibly equal to negative 9. Over here, adding 8. R is possibly equal to 8. Remember, I'm saying possibly because we have to check and plug them into the original problem, the original equation, to make sure they work. So I'm going to check negative 9. Okay, so 72 minus negative 9. Remember, that minus negative becomes plus positive, equals, and then r. So r would be 9. So does square root of 72 plus 9, which is 81. So does square root of 81 equal 9? Okay. Or I'm sorry. This would be negative 9 here. My bad. Because we plugged in negative 9 for r. R would be negative 9. So our question here is the square root of 81 equal to negative 9? The answer, square root of 81 is 9. And that is not equal to negative 9. So negative 9 we would call extraneous. Okay? So that's not going to be part of our final answer. Let's check 8. Remember, when we get two answers, it's possible that one works, it's possible that both works, it's possible that neither could work. So let's check 8. And wherever in the original problem I see an r, I'm plugging in 8. So square root of 72 minus 8. We're saying, is that equal to 8? Okay, so square root of 72 minus 8, square root of 64, is that equal to 8? Square root of 64 is 8, so 8 equals 8. Boom. Okay, so what we found there is r equals 8. That's our only valid answer. Okay, that's what you would put for your final answer. You would not include negative 9, because this is the only one that works in the original problem. Let's try another one. Okay, so say I have 36 minus 5r equal to r. Again, just like this one. Since we have a square root, to get rid of that, I have to square both sides. And whatever I do to one side, I have to do to the other. So square both sides. Again, that gets rid of the square root. So I have 36 minus 5r equals r squared. Remember, I need to have this side equal to 0 because it's a quadratic equation. We know it's quadratic because it has an r squared, or could have an x squared, some variable squared. So I'm going to subtract 36, add 5r with both sides. So 0 is now on the left side, and I have r squared plus 5r minus 36. Remember, when we factor, and I have included your factor sheet in the folder, okay, for this day's assignment. I'm looking for factors of negative 36 that add up to 5. So we look at 9 and negative 4. Okay, those would be the two that would get the job done there. So I would have r plus 9, and I would have r minus 4. Okay, so r plus 9 equals 0, r minus 4 equals 0. Remember, you set each factor equal to 0. R is possibly equal to negative 9. R is possibly equal to 4. Remember, I'm going to check now. So if I check negative 9, okay, so checking negative 9, square root, it'd be 36 minus 5 times negative 9. Okay, we're saying, is that equal to, remember, it's just r over there, so is that equal to negative 9? 36 plus 45, so that would be, remember, negative 5 times negative 9, that would be 45. So 36 plus 45, that would give me 81 in here. Square root 81 is 9. 9 is not equal to negative 9. Okay, so similar situation to here. So we would say negative 9 is extraneous. And let's check 4. So to check 4, again, I'm plugging in. So we're saying, is the square root of 36 minus 5 times 4 equal to 4? So is that the case? So 36 minus 5 times 4 would be 36 minus 20, which would be 16. Okay, I'm just kind of shortening there again. 36 minus what would be 5 times 4, 36 minus 20 is 16. So is the square root of 16 equal to 4? Yes, it is, right? 4 equals 4. So 4 would be the only one, that's the only valid solution to the problem, because it's the only solution that works in the original equation. Okay, so negative 9 you would not have as part of your answer. All right, so I'll give you some time to take a look at those two, and then we'll do a couple more examples. All right, so remember, with these types of problems, square both sides. Okay, make sure you get one side equal to 0, because that's what we need to solve quadratic. Factor, set each factor equal to 0, then you get your possible solutions. You have to check them. Make sure they work in the original equation. If they don't, remember, it's extraneous and it's not part of the original, or it's not part of your final answer. All right, let's look at another one. So let's say I have x equals square root of x plus 12. Okay, and we're going to do it the exact same way. To get rid of the square root, remember, I need to square both sides. So squaring this side, squaring this side, I get x squared equals, square root goes away, so I have x plus 12. Remember, this is really 1x plus 12. And to get this side equal to 0, how do I get rid of 1x? Subtract 1x, right? How do I get rid of 12? Subtract 12. So I would go minus 1x minus 12 from the left side. Remember, right side, all that goes away, so that's now 0. I'd have x squared minus 1x minus 12. Okay, and now we want to go ahead and factor. So we look and see, okay, two factors of negative 12, two numbers that multiply to negative 12 that add up to negative 1. So we're looking for numbers that are 1 unit apart here. That's kind of a little thing to think about. So it would be negative 4 and positive 3. That would add up to negative 1 and multiply to negative 12. So I have x minus 4, x plus 3 equals 0. Remember I said each one equal to 0. And x minus 4 equals 0, add 4 to both sides. So x equals 4, possibly x equals 4. Remember we have to check it. Subtract 3, so x is possibly equal to negative 3. Now we're going to check. Okay, so I'm going to check x equals 4. So check, and that's my check mark there, which means we're checking our answer. So wherever I see an x, I'm going to put a 4. Remember the original was just x equals square root of x plus 12. So I would say, does 4 equal square root of 4 plus 12? Okay, 4 plus 12, that's 16, right? So 4 equals square root of 16, right? Is that the case? Yes, because square root of 16 is 4. That is true. So we know 4 works. Okay, we know that works, but we have to check negative 3. So let's do that. Okay, so to check negative 3, so we're going to say, does negative 3 equal square root of negative 3 plus 12? Negative 3 plus 12, that's 9. So negative 3 equals square root of 9. What's square root of 9? Square root of 9 is 3. Okay, that's not equal to negative 3. So negative 3, that's going to be extraneous. Remember, that is not part of your final answer. So when you enter your final answer, whether you're typing it in or whether you're selecting from a list of answers, all the possible solutions, the only one you'd mark is 4. Okay, negative 3 is not an actual valid answer. All right, one last one here. This looks a little different. So x equals square root of 2x. Okay, 2x is inside the square root. Again, same strategy. Square both sides. Okay, so I got x squared over here equals, remember, squaring takes away the square root. I got x squared equals 2x. I still need to have one side equal to 0 because I still have a quadratic with the x squared. So I'm going to subtract 2x from both sides. So now the right side is 0. I got x squared minus 2x equals 0. Okay, so we can solve this by factoring. But we're thinking along the lines of a GCF, factoring by greatest common factor, which we did earlier in the semester. So what do both terms have in common? An x, right? So we factor out an x. Remember, factoring out means we divide by x. So x squared over x, I'd be left with just x. 2x over x, right, is just 2. So I'd have x times x minus 2 equals 0. That's the factored form. Set each one equal to 0. So x equals 0. So that's one of our possible solutions. X minus 2 equals 0. Add 2 to both sides. So x could possibly be 2 as well. So what do we have to do to verify? We have to check. So I'm plugging into the original equation. So I'm going to check 0. So does 0 equal square root of 2 times 0? So I plugged in 0 wherever there was an x. So 0 equals 2 times 0. Remember, anything times 0 is 0. So square root of 0, 0 equals 0. So yes, 0 is a valid solution. Let's check 2. Okay, so wherever we see an x, we're going to plug in a 2. So does 2 equal square root of 2 times 2? What's 2 times 2? 4, correct? So 2 equals Does 2 equal square root of 4? Square root of 4 is 2, so 2 is equal to 2. So yes, in this case, we have 2 valid solutions. Both of them work in the original equation, so your answers are 0 and 2. Okay, so remember, we always have to check our answers. If they are extraneous, they don't work in the original equation, do not put them as part of the final answer. Okay, until next time, everybody take care. This is Mr. P. See you later.